Hi there. In this video, my goal is to help you understand and hopefully see the computer organization in action. In other words, how does data actually flow through the computer when we look at it via the computer organization setup? All right. Now, this is going to be a general description. It's not 100% detailed with all the actual details that go into it, but it should provide you with a good overview. I do expect you to already have learned about the computer organization itself and the definition of a computer. If you haven't, please make sure you've already viewed those video clips, the ones that describe a computer and each of these computer organization components. All right, let's go ahead and get started. So, first off, let's start off with something in mind. All right. Now, humans write instructions for computers. We built computers so that they can solve our problems and reduce the tasks for us. Right. So, when a human writes instructions for a computer, that person is known as a programmer. That's the title that they receive. So, a programmer writes instructions in a language that a computer can understand. And those instructions, those are known as a program. All right, so that's what we have here. We've got this programmer over here. Now, here might be an example of a binary program. And I just made this up, okay, like literally just so that you can have something to visualize. But it's a program. There are instructions that the computer can understand. You can't make sense of it, but a computer can. And it's written in binary. Now, let's pretend that this code that this programmer over here wrote, let's say it translates to this in English. So if we were to take this in binary and translate it to English, let's pretend it means this. 5 steps that we want this computer to follow. The first step is to ask the user to type 2 numbers. Second step is to send 2 numbers typed to the ALU. Third step is to send those 2 same numbers that were typed to the output device. Fourth step is to store an answer, whatever answer was derived from ALU into memory, and to store the answer from the ALU to the output device. I'm sorry, to send it to the output device. So that's what this program will represent. All right. So what we're going to say here is that this program is already loaded onto this computer over here. Computer is represented by that green square. These are all the components that are part of it. So pretend we went to the store and we've got this program and and we bought this computer. Well, this program would already be installed. Kind of like when you buy a phone and it already has some apps installed, same idea. This is already loaded onto or installed into the computer's memory there. All right, let's go ahead and continue. So now we've got the simple computer, which does one thing. When we turn it on, the one thing that it does, which is to add stuff, add 2 numbers specifically, that uh, that program is already stored in memory. So as soon as it's turned on, that program is loaded by the control unit. So the control unit already knows how to do this. It just grabs it from memory, grabs that program from memory, I should say, and loads it. And basically says, okay, I'm going to start following these instructions. Right. So here is the control unit. It's got a copy of this program that it got from memory, and it's going to start executing that program. Execute means it's going to start following the instructions. All right, so these are the instructions in English for us. Okay, so let's go ahead and continue. So now, what's the first step that happens? So we're going to follow along here with the English version of this program that it's following. The control unit, I'm going to call it CU for short, control unit. The CU is going to send a command because step 1 says ask the user to type 2 numbers. So the CU is going to send a separate special command to the output device asking the user to type 2 numbers. So there's the command. It's going over to the output device. The output device is going to receive that code, that command, in the form of binary, right? It might not make sense to us, but this output device knows what to do with that. And what does it mean? It means, according to what this monitor understands, which is our output device, it's like, oh, okay, this special code here is telling me to write these 2 sentences on the screen. Type a number and then type another number. So that's the image that is being painted according to what these instructions mean, right? Okay, so that step is done. Now, the human sitting there staring at this. So the user is going to provide, the user is a human, is going to provide two numbers, right, using the input device, which in this case is a keyboard. So there's the human looking at that keyboard saying, okay, I need to answer this question. So the user is going to type a 2, and then they're going to type a 5. When they type a 2, these are the binary signals that are being sent in. When they type a 5, these are the binary signals that are going to be sent in. So these are sent into the computer through that input device. So there they go. They're making their way into the computer. Now, the control unit is going to be like, hey, what's this stuff coming in? Right? I've got two things coming in. I've got a 2 and a 5. What should I do? Well, it refers back to the instructions, the same one that it loaded over here from memory. And the next step, say, send two numbers that were typed to the ALU and send two numbers typed into the output device. All right, I just am doing these two steps together because they're kind of related. So we're going to take, if we pretend we're the control unit, we're going to take these two numbers and we're going to send them to the ALU, and we're also going to send those two numbers to the output device. So here are those two steps, right? The first thing it said is send the two numbers to the ALU. So there's the 2 and there's the 5, and the ALU has received them and is going to start adding them. The other thing is it's going to send the two numbers to the output device. So there they are, plus some other code, right, that is meant for the monitor to make sense of. So right here, the ALU is going to go ahead and add those two values, and it's going to come up with 7. And over here, the monitor is going to make sense of this binary code, and it's going to say like, oh, okay, you want me to draw a 2 and a 5 there, right, and put them right there. So that's that step there. After that, the next step is store the answer from the ALU, which is this 7 shown in yellow. Store that answer from the ALU into memory. So it's going to, the control unit is going to make sure that that 7 makes its way over to the memory unit by issuing a store command. So it's making its way down over there into the memory, right, which represents the 7. So there it goes. 7 has been placed into memory, maybe for some later use. Okay. Next up, the CU, right, is going to follow this last step, send the answer from the ALU to the output device. So we've got this answer here, and it's going to need to send it to the output device. So that 7 makes its way over here along with some other special command. And when the monitor, the output device receives that, it's going to say, oh, okay, this means show a 7 on the screen, right? And put the word SUM. So it displays that on the screen. Hopefully this, I'm sorry, that is the end of the scenario there. So hopefully this gave you a good kind of in action type of example of how computer organization enables or allows for a user to interact with a computer, and the computer is able to take all that information, the input, and then process it, right? So it's going to process it and do something with it so that it could provide some type of output to the user, something that makes the user's life easier. If you have any questions, please make sure you replay this and make sense of everything that you've seen so that you're better able to understand how data flows, specifically binary data flows, through the computer model. And make sure you're aware of all the roles of each of these items so that you can come up with your own small example, sort of like this one.